Today I will show you how to work in Simulink Coder. It will be just a very short, let's say not bonus, but something that might be useful for you in the future. Because last week we have been working just with the signal from Simulink that were producing digital signals. And I found one useful feature that you could use for the project, and that's the serial line. It looks like that we will not be able, at least for the first project, to go to the labs, so I have to find the way to allow the communication between the Nucleo board and the PC if you have the board yourself at home with you. And for this we'll be using the serial line. Let's take a look on how we can actually do this. The idea is as follows. Here we will have one code, one program in Simulink that we will upload into the Nucleo board, and we will have a second code running on the PC, also in Simulink, that will read the data, and both will communicate through a serial line. So for this I ask you to install actually one additional toolbox, because otherwise, well, it might be possible to make it in Simulink as well with some basic functions, but I think this is easier. So if you did not install it yet, then it's no problem, but install it a little bit later. You need to go here to the add-ons, and you need to search for the instrument control toolbox. So let me show it to you. And this toolbox, it's not missing an R here. It's one of the toolboxes for Simulink that allows you to communicate with different instruments. So basically there are functions that allow you to communicate through serial line. Here you can see it communicates with TCP/IP, with UDP, so different protocols, and other buses that we will not use in this class. Basically, you can design code in Simulink that will read the voltage from an oscilloscope, that will read some signals from a multimeter, and so on. It is contained in our license for MATLAB, so if you have the university license, it is there. So after you install this and you restart MATLAB, then we will have new toolboxes that will appear in Simulink. So here you can see I have instrument control toolbox, and here we have different options how we can actually send the data from the instrument to the PC or back. So we'll take a use of this icon, the serial receive, a little bit later, and I'll show you how to configure it. We will first create the code for the Nucleo board. So I'll just quickly drag the icons as we done last week. So from this we will use the blocks that we have available for the Nucleo board, and the serial line is this SCI write, and we'll just drag it there, and we'll configure it a little bit later to see how we can use the serial line on the board. So this will be my serial line. I will write to the serial line with the CPU on the Nucleo board. I need a source of signal, so let's say, for example, I will use a sine wave like that. It's just to have some signal. I will now connect the two blocks together, and I just need to configure that this will work at some specific sample time. So now this needs to be switched to sample based, and now you can see here we have different parameters. So samples per period, let's leave it maybe 250. I will leave the amplitude to 1, and sample time, let's make it sample time ts, like the variable that will be defined in MATLAB. Now so far it will give me an error because I did not define this variable in MATLAB yet.
Excuse me, Professor.
Hmm?
I'm seeing your screen at the top of my screen, very small. Why it's not the like the main screen? I don't
Yes,
know
I
if
have the
I'm.
same
I have
problem.
the same issue also.
Yeah.
Uh-huh. I will
I'm seeing all the other members of the team as well, like
It's also
mm,
like
blank screens.
it's like
if you
Zoom.
if you're here in this window, maybe you can try to double click my screen.
I tried actually, it didn't work.
Yes,
Maybe
it's working
you
for me,
use
but
the
when I clicked on your screen, yes, it's working, but it's Zoom.
Now it's
Now,
working.
now it's working. Right.
Okay.
I
or
did not
maybe
change
you can
anything.
do the right click and then pin it.
Right
Actually,
click and do what?
right click and
Right
pin
click
it.
and pin it. Okay,
Pin.
yes,
Yeah.
Oh,
yes.
okay.
Yeah.
Okay.
Or
Perfect.
Yes.
spotlight so that it's on me.
Okay. Sorry for interrupting. And the lecture is not being recorded. Oh, okay. It's being recorded. Thank you.
I'm doing a record on my PC, so I will have the video later and I will post it.
Okay. Thank you. Thank you.
So here we have the TS not defined, so I need to go to MATLAB and I need to define my variables. So let's say 0.01, and here someone mute your microphone. Someone,
Oh, sorry.
I hear you eating some candy. So TS will be 0.01, for example, and now if I go back to my blog, the TS is already defined. So this is my program that I will upload to the Nucleo board. It still gives me some problem. What's the problem? Refresh. Yeah, it was just that it did not update the TS variable. So this will be my code that I will compile and upload to my board. I need to tell Simulink that I want to compile this for the Nucleo board. So we do this in the settings of the model. It is necessary to change to fixed step here so that we have a fixed sampling period. And in solver here I will set my sampling time to TS as well. So every time the model runs, it will take one sample from this signal generator and send it to the serial line. In hardware implementation, by default you have a code generated for a PC. So we need to select our board, which is this Nucleo F7F7ZI. It will switch the compiler to the correct board, and now we just need to tell the device in hardware resources what will be this configuration of my serial line. So here you can see that it by default is working with serial line number 0, which is here, SPI 0, no, SCI 0 here. And here are my parameters. So baud rate is 115,200. So this is actually in bits per second. And this is a hardware line that is available on the board. So I will leave it like that. I will leave this default configuration. Uh, so this is the configuration done for the Nucleo board, and now I can compile my code here. You see that here the hardware tab has appeared, and I will build and deploy that to the board. Now I will switch to infinite time over there, so that the code runs until I unplug the power, and I can start building. Now, in order to show you that this really works, let's see. Here I have a second program that you may download from the internet for free as well. It's called Real Term, and it's one of the programs that you may use as a serial terminal. So the data that will start to appear here on my board will be the data that are being sent here from this block. So let's see now. My port is closed. I will just build and deploy my code to the Nucleo board. It will compile the code, and if everything is fine, it will download the code. So here we'll be able to see what is happening. And after this has started, now we will be able to see here the incoming data from the board. Now on my computer, the board here was detected as a serial port number 4. In your case, it might be a different number. So in your case, it might be 16 or 2 or whatever. You may find this in the settings of your computer in the device manager, where actually was this defined. So let me just wait until this compilation is finished. Now it's finished. Now it downloads to the board, and now you can see that when I have opened the board here, some gibberish number starts to appear, and this is actually what is being sent from the Simulink. So this is shown like characters. If I switch to integers, for example, like that, then those numbers are generated by Simulink, and if we would plot them in a chart, now this should be like a sine wave that is being generated from this board. So now we know that our program is working in the Nucleo board, and the second code that we're gonna create will be for Simulink. So let me create the second code. I'll just open the new environment, and this is where the instrument control toolbox comes in. We need to use the serial configuration block like that, and the serial receive block, and in the configuration ports we need to select where is the board connected. So if you open that, it will detect the serial ports on your PC. I have currently 2, so it's COM4, that's my board, and obviously we need to use the same speed on the Nucleo board and on the PC. So it's 115,200, like that. The other parameters, we can leave them by default. It's 8 bits and parity and so on, but this is like the normal settings. So this configures the COM port on the Simulink, and now in this serial receive block, I just need to tell that I want to use COM4, and eventually if there are some termination characters, which in my case there are not, but you can send, for example, text messages. So this does not have to be a sine wave. It can be a text message, or it can be a number that is terminated by some character, like by enter, and you can actually configure all this here. So we can have sample time set by the variable. I just leave this for the time being, and now we just need some output to show the actual numbers. So let's use for example the display here as a sink, and we'll connect that like this. So now again I will run this in infinite time, and if I start that, it will show us the numbers that we have here on the display, and this is what's coming in from the serial line, from the nuclear board. So we can, for example, add also a scope here like that. Now in my case it will most likely not be a sine wave, because we did not care properly about the number types that we have here in Simulink. So here this probably sends floats, and we would need to convert that to integers, and to send as integer and then convert it back to floats in this second code. But anyway, here we can see that sometimes is happening, so that we get some data, and now this is basically just a problem of conversion of numbers that are coming from this block as floats into the serial line. The serial line actually can send only integers, or not integers, but it can the number that you are actually sending is just the 8-bit number. So here you need to convert it to an 8-bit number, and here you would need to convert it back. Anyway, at least for the first project, this should be sufficient, because you can produce just 0 or 1 here, not a sine wave, and you can send it on a serial line, and you could see it here on the scope in Simulink in second code. So this is just an addition to last week's class. I have uploaded the presentation with this in Moodle, so you have it available, and I have also uploaded those two examples for you in Simulink. So here in example Simulink, now this first one is the example for the nuclear board that I was just showing you, and this is the example for Simulink how to read the actual serial line. Now let me tell you what we will do next, and the next will be semester project number 1. So I will first explain you how this will work, and then at the end I will assign you this project. So I have actually uploaded that to Moodle as well. So I will just open the assignment, and I will explain you what will be the goal of this semester project. The goal will be that you will be given a mathematical model. For example, here you see this is a simplified mathematical model of an aircraft in flight. Now all the models are taken from some reference, so it's always given at the end here, where you can actually take a look on more details about the model. Each of you will have an individual assignment. So for example, one student will have assignment 01, which is this one. One student will have assignment 05, which will be something else. And in all cases,
Can I take the first assignment?
no, I will assign it randomly.
Okay.
So I will first explain you how this will work. So I will assign you the number of the assignment. So in all cases, you should implement the model in Simulink in real time. In some cases, the model is given as a transfer function like that, and here is how the transfer function looks like. In some cases, it is given like a differential equation. So in this case, it will be implemented in Simulink like a differential equation. There is always a very short description what the system is, and some picture explaining the variables. Now if you want to dive deeper into the description, you need to go to the reference. So for example, here you need to take a look on the original web page, and you need to find out what is the input and output. For example, in this case, the input of this system is the angle, theta here, and the output is the ball position. So you will first implement the model of your system in Simulink real time. In some cases as equations, in some cases as transfer function. Then you will basically do the transient response of this system. So the input to your system will be a step function, and now there will be several possibilities where this step function will come from. For example, case A is that the step function will be created directly in Simulink, and this can be run in continuous time. So what you will do is that in Simulink, let's say if your system will be a first order system, then the transfer function, if you have here some output y, then the transfer function looks like this. Here it's an exponential response. This is the input of the system y, and the input, of course, if I'm looking for a transfer function, then this well, it's not a very straight line, but this should be vertical line, and this will be your input x. It does not have to go to the same value, because you can have a different steady state here for y. That depends actually on the system. So like this, we will get a transient response in Simulink. In order to repeat the experiment and to keep it running, the input will not be actually just this step function, but it will be like a rectangular wave, like that. And this means that here you will have another transfer function, but now it will go to 0. So like this, you will create that in Simulink. This is fairly easy. Then you should create this in Simulink real time with inputs and outputs that come from the Nucleo board. So we will keep a model in Simulink in real time of your plant, and the step function, the square wave signal, will actually come from the Nucleo board. Originally, what I wanted to do is that this will be a real square wave signal coming like an analog signal to the PC in the lab. But as unfortunately we don't have access to the lab, then we will simulate it by the serial line. So what we will do is that in here, this code, that's what you will run in Nucleo board, except that this will not be a sine wave, but it will be a square wave, and this you will upload to your Nucleo board, and then you will have a different model, something like I have here, that is reading from the serial line the number, if it's 0 or 1, and here will be your plant, and on the output, so basically you will do this, you will take the data like that from the serial line, then in here there will be your model for the plant, and here you will have some scope where you will show the transfer function, and you will see that there will be something different. First of all, it will not run in continuous time. So it means that here we'll have some steps, and the actual transfer function will look like this. Well, it will not be as bad as you see here, but I want to let's say highlight here the differences. Like that, and this means that there will be some steps. this step is due to the sampling period, so this will be TS, and as you will change TS, it will get better or worse as you are increasing or decreasing it. And this will come from the AD converter, or from the, let's say, granularity of your device. In any case, you would see this in the real world on the oscilloscope. So this will be coming from the resolution that of the numbers that you will have basically in the nuclear board. And the goal of this first project is that you compare and plot the differences of those two transient functions. So compare the model purely in Simulink with the model in Simulink real time plus the nuclear board, and plot the differences. The differences will basically be this difference between this smooth function and between this stepwise function. And last task is to find out at what sampling period your code has to run in real time so that it models, I say, nicely this this system. Some models will require a higher sampling period, and some will be sufficient with low sampling period. If you require some parameters for the model, then you need to look in this reference always to give you some examples. Or you can just model, for example, this system can be modeled just by, let's say, designing it physically in like an idea. You say, okay, let's make this 1 meter, let's make this diameter something, I don't know, 20 centimeters, and so on. So in some cases the parameters are given, in some cases you need to look in the reference, and in some cases you need to, let's say, figure out what the parameters are.